we are gonna start our video with a discussion of section 11.5. We're gonna talk about the distance formula. If you have on a coordinate plane a straight line that goes through 2 points, and we say that one of these points is maybe 2, 3, and the one over here is maybe -3, 3. If I want to know the distance between those 2 points, all I would have to do is count, and I would go, I have 3 units there, and I have 2 units there, so the distance here is 5 units. That's fine as long as you have a horizontal line or you have a vertical line where you can just count the units. But the problem is sometimes our lines have a slant to it. So there has to be a way to be able to find the distance between 2 points if they incorporate a slanted line. Let's say we have a point over here that's 4, 1. And then we have a point over here that's like -2, 4. And I want to know the distance between those 2 lines. Well, I can't count because it's not a horizontal line and it's not a vertical line. So there has to be a way to do it. Well, you actually could square it out and do the Pythagorean theorem on it, which is what you've been working on. And you know that the distance from -2 to +4 is 6. So across the bottom here, I have a distance of 6. Then from +1 to +4, I have a distance of 3. Well, if you notice, if I make it into a right triangle, I can square it out like that and find the distance from there to there because that is the hypotenuse. So you know your Pythagorean theorem would say 3 squared plus 6 squared is equal to c squared. So we've got a 9 plus a 36 equals c squared. So that's going to be a 45 is equal to c squared. So c is going to equal to 9 because I'm going to take the square root of both of those. So I would know the distance between those 2 points is 9. That's great if you want to draw it out every time and make your right triangle, but sometimes you're not going to want to do that. So there is a distance formula that was created with the concept of doing this on a coordinate plane. The distance formula looks like this. Distance is equal to the square root of the difference between the x values squared and the y values squared. Now, I can take that formula and I can just know this point and this point and plug it into the formula without ever drawing it on a coordinate plane. So let's say I want these to be x sub 2 and y sub 2. That makes this x sub 1 and y sub 1. Doesn't really matter which one you choose as which. So distance is equal to the square root of -2 minus 4 squared plus 4 minus 1 squared. If I start with this one with my x, I must start with this one with my y. So the distance is equal to -6 squared is 36. 4 minus 1 is 3. 3 squared is 9. So the distance is the square root of 45. Okay, the square root of 45, and I'm not sure how I got 9 out of that because it's the square root of 9 times the square root of 5. So it would be 3 on the square root of 5, my mistake. Okay, over here, same thing. Square root of 9 times the square root of 5 is 3 on the square root of 5. Don't forget to break it down as far as what you can go. Let's do another one of those without having the drawing on the coordinate plane. I'm going to leave the distance formula up there. let's say they give you 2 points, 2, 3, and 4, negative 4, 6. Now you can put them on a coordinate plane, but let's say you don't want to do that, and you just want to know what the distance between those 2 points are. Well, all I'm doing is plugging in. D is equal to the square root of 2 minus a negative 4 squared plus 3 minus 6 squared. So I work this out, and I have the square root of, that's going to be, I'm going to add the opposite of the second number, so it's positive 6 squared, which is 36. This, I'm going to add the opposite of the second number, so I have a negative 3. Negative 3 squared is 9, and it just happens that it's the same square root as what I had before. So at this point I know that's 9 times 5, or 3 on the square root of 5. Okay, and so that's your answer to that problem. All right, now I'm going to have you try one, and what I suggest is after I put the values up here, you pause the video, you do the problem, and then you start the video back up to see if you did the problem correctly. So you try this one, okay? Find the distance between 1, 2 and negative 3, 0. So go ahead and pause the video, work that problem out, and then come back and see if you get it correct. The distance is equal to the square root of 1 minus a negative 3 squared plus 2 minus 0 squared. So the distance is equal to, I'm going to add the opposite of the second number, so it's 4 squared, or 16, and 2 squared, which is 4. So the distance is equal to the square root of 20. 20 is the same as the square root of 4 times the square root of 5. So that's 2 on the square root of 5. Break it all the way down. All right, going on to a different type of problem, still using the distance formula. Sometimes they'll give you a distance and they'll leave out either an x or a y value, so you have to work backwards. An example of that might be, you know that the distance is 10 and your points are 7, 5, and A, negative 3. So all I'm doing again is plugging in, but this time I know the distance, it's 10, and I go 7 minus A squared plus 5 minus a negative 3 squared, and I begin to work this out. Well, the only thing I can really do over here underneath the square root is figure out this one. That's going to be 8 squared, so I have 10 is equal to the square root of 7 minus A squared plus 8 squared is going to be 64. Well, I can't get to any of this until I get rid of my square roots. So I'm going to square both sides. When I square the 10, it becomes 100. When I square that side, I get 7 minus A squared plus 64. Then I began to work my way to get to that A. So the first thing I'm going to do is subtract 64 from both sides, which gives me a 36 equals 7 minus A squared. Well, to get rid of that squared, I'm going to have to take the square root. So when I take the square root of both sides, I get plus or minus 6 is equal to 7 minus A. I'm going to come up here. If I write below this line, you're not going to be able to see it. So hopefully you'll be able to see this done out. So 6 is equal to 7 minus A, and negative 6 is equal to 7 minus A. I'm going to subtract the 7. I'm going to get a negative 1 equals negative A, or A is equal to 1. I'm going to subtract the 7 again down here, and I'm going to get a negative 13 is equal to negative A, or A is equal to positive 13. Both of those are your answers. Okay, so you're going to have two answers for these because you actually don't know which direction from this that's going to go. So there's two possibilities there that would have the same distance. All right, I'm going to give you one of these to try. Again, pause the video, do it, and then come back. All right, distance is equal to 10, and your points are 3, -1, and A, 7. So go ahead and work this out and then come back and see if you got it correct. All right, I'm going to plug it into the formula. 10 is equal to the square root of 3 minus A squared plus -1 minus 7 squared. The only part I can do is right there. So I have 10 is equal to the square root of 3 minus A squared plus, if you add the opposite of the second number, that's going to be a -8. So -8 squared is 64. Okay, then I got to get rid of the square root. So I'm going to square both sides. So that's going to be 100 is equal to the square root of 3 minus A squared. Actually, your square root is gone. Plus 64. I'm going to add the -64 and get a 36 over here. And again, I'm going to take the square root of both sides. So I have plus or minus 6 is equal to 3 minus A. That separates into two problems. Positive 6 equals 3 minus A. And -6 equals 3 minus A. I'm going to subtract the 3. Going to get a positive 3 here equals -A. So A is going to equal -3. That's one answer. Then I'm going to subtract the 3 here, and that's going to give me a -9, which is going to give me a -A. So A is equal to +9. Those are your two answers. I think what we're going to do, since this is our first day of trying to do this, we're going to stop with this information, and I'm going to give you the homework. Now remember, the homework is due by noon tomorrow, which is noon on Thursday, and we'll proceed through there. The one thing I ask is when you send me your homework, make sure you're putting your name on the top and you're leaving me space to correct next to it. All right, so your homework, and this is all has to do with the distance, is going to be page 613, 14 through 32 even. And again, that is due by noon Thursday. Then you will have your next video on Friday.